Alright, so what we're going to be going over right now specifically is rational equations and how to simplify, how to solve for anything with rational equations. We're going to go over a few problems to make sure you guys know what to do. Okay, so let's go ahead and start with an easy one right here. Start with number 1. It says we need to simplify this. So when you simplify, sometimes you simply need to factor it. You guys know how to factor. So we're looking for two numbers that add up together to equal 11, but the same two numbers, when you multiply them together, equal 24. Whenever you do this, you always start with what's called the factors. And what are the factors of 24? So start with factors. So for example, like 24 times 1, or 12 times 2, or 8 times 3, or 6 times 4. Those are all the factors. Now only one set of these factors actually add up to an 11 and multiply together to equal 24, and that's the 8 and the 3. So that's why this is going to factor to x plus 8 and x plus 3. And right here, this one is a little bit different. Switch colors here. We are actually looking for two numbers that add together to equal 4, and those same two numbers multiply together to equal negative 32. Well, what are the factors of 32? 32 and 1, 16 and 2, 8 and 4, and that's it. Well, which ones could get me to a positive 4, but a negative 32? Well, it would have to be a positive 8 and a negative 4, and a positive 8 and a negative 4. So we have what's called x plus 8 and x minus 4. Now, if this was f of x equals, we would have what's called removable discontinuity here. But here we're just simplifying. So all we're doing is just simplifying it. Okay, and so we're left with x plus 3 over x minus 4. I'm not going to tell you the answer, but hopefully you can see the answer somewhere. All right. But when we get to solving for x, okay, what you have to find is you got to find what's called the least common denominator. All right, so everybody sees that this denominator has a 3 and this denominator has an x. Well, the least common denominator is going to be 3x. So what I'm going to have to do is I'm going to multiply. All right, what I'm going to do is I basically need to multiply everything by a 3x. That's one way of thinking about it. Okay, so we're going to multiply everything by a 3x, which means I got to distribute n and n and n. So I'll go and do that. Ready? So I have 5 times 3x, which is 15x, and that's all over 3, minus 2 times 3x, which is a total of 6x, over an x, equals 3x times 8, which is 24x over an x. Well, what you'll notice is that this will simplify to 5x. These x's will cancel out. You'll be left with minus 6. These x's will cancel out. You're left with 24. So now we can add 6 on both sides. We get 5x equals 30, x equals 6. So that's one way of doing it, okay, where you multiply everything by what's called the least common denominator. What's another way we could do this? So check this out. So if I have 5 over 3 minus 2 over x equals 8 over x, I know I got to make a common denominator, which would need to be a 3x. So watch what I do. Another way of doing it is this. You multiply this by x over x. You multiply this guy by 3 over 3. And you multiply this by 3 over 3. Let's see what we get here. All right? So we get 5x over 3x minus 6 over 3x equals 24 over 3x. Now, here's the cool news. In a fraction, for example, let's say I had 1 over 2 plus blank over 2 equals 7 over 2. All right, and I'm like, what number would you have to plug in there? Hopefully you would know that would have to be a 6, because 1 plus 6 is 7, because these are all the same denominator. Well, if they're all the same denominator, if I have a 3x, a 3x, and a 3x, then I can set this whole thing equal to each other. So I could set it up, and for me, sometimes it's easier to think of it this way. I can set it up as 5x minus 6 equals 24 without having to do all of the distributing and canceling out. I just got to make the denominators equal, then I know the numerators will be equal as an equation. Then you add 6 to both sides, divide both sides by 5, and you still get the same answer. Okay? So let's do a little more complicated one. Okay? Like this one. All right? It's a little bit more complicated. So let's check this out. We have 3 over x minus 5 minus 20 over, now this factors to, this is a difference of squares, this factors to x plus 5 and x minus 5. That's what they factor to, okay? Equals 2 over x plus 5. Now, this is going to be my least common denominator. It has an x plus 5 and an x minus 5. So what I'm going to do is I'm going to multiply this guy by an x plus 5 and an x plus 5. And I'm actually going to multiply this guy by an x minus 5 and an x minus 5. Okay? So here's what we're going to get. We get 3 times x, which is 3x. 3 times 5, which is 15. All right? And that's all over the same denominator now of x plus 5 and x minus 5. Minus, we have 20 over x plus 5, x minus 5. Equals 2 times, so remember, just like I distributed to this, I'm going to distribute it to this, equals 2x minus 10, okay, over x plus 5, x minus 5. All right, now, if all of these are the same, if all these denominators are the same, then I can take this minus this and set it equal to this. So now, that's all I'm going to do, because I made all of my denominators equal. I'm going to take 3x plus 15. I'm going to take away 20. I'm going to set it equal to 2x minus 10 and go from there. So here we go. I know 3x stays there. 15 minus 20 is negative 5 equals 2x minus 10. Now I'm going to add a 5. Okay. And I'm going to add a 5. Right here. I meant it to go a little bit further over, sorry. Add a 5. Very good. Okay, now I'm also going to take away a 2x from this side and take away a 2x from this side. So it looks like I get x equals, that zeroes out, x equals a negative 5. So I get, my answer is x equals a negative 5. But that's a problem. There are 2 solutions we are not allowed to have if we happen to get them. One of the solutions that we couldn't put there is a 5, because that would make that denominator equal to 0. Another solution that we could not get is a negative 5, because that would make that denominator equal 0. So I could basically have any number, any other number would have worked except for a 5 and a negative 5. So this is what's called an extraneous solution. All right? So an extraneous solution is a solution that you did all the math correct, but when you plug it in, it just doesn't work. It doesn't matter how well you did the problem. It's just not going to work. But I'm not going to tell you the solution, but I'm going to tell you the answer is there's not going to be one for this particular problem. Okay? I'm sorry. It's just not going to work. We did one like that. Ooh, let's get one where we actually have a solution. So we'll do one more here where we actually have a solution. All right, let's take a look at this one right here. I'm going to rewrite it. try to do as neat as I can. I got 2 over x plus 2 plus 5 over x minus 2 equals 6 over x plus 2 times x minus 2, because this is called the difference of squares. So this is going to be my least common denominator, all right? It's going to be my least common denominator. So here's what I want you to understand. This guy needs an x minus 2, and this guy needs an x plus 2. So what I'm going to do right over here is I'm going to take this side and multiply everything by an x minus 2. And see here, I'm running out of room here. I'll erase this real quick. I'm going to multiply this right here by an x plus 2 and an x plus 2. All right, sorry if you... So basically, now I'm going to take 2 and multiply it to those. So I have 2x minus 4, because I distributed to both, plus 5 times x, 5 times 2, plus 5x plus 10. Do you see how they have the same denominator? So technically, this right here, I can put this all over one denominator known as x plus 2 and x minus 2. So instead of separating it, now I'm just putting it all over one denominator, equals 6 over x plus 2, supposed to be a plus 2, and an x minus 2. Now, if the denominators are equal, which means if this denominator right here is equal to this denominator, then these numerators right here have to be equivalent. So this has to be equivalent to this. So now I'm just going to solve it. All right? Now it just becomes a linear equation, okay? Which just basically means just all on one line. And just a term of x. All right? Oh, our schedule's up here today. Sorry, I was answering a question. So 2x and 5x make 7x. All right? And then if I do negative 4 plus 10, I get 6. And if I take away 6 from both sides, I get 7x equals 0. X equals 0? Really? All that work for 0? Well, let's see if it works. You know what? Why not? Let's just plug it in. See if it works. Plug in a 0, plug in a 0, and we'll plug in a 0. Okay, so here we go. We plug in a 0, we get 2 over 2. Plus, we plug in a 0, and we get negative 5 over 2. Okay? We plug in a 0 here, we get 6 over negative 4. Is 2 over 2 plus 5 over negative 2 equal to basically negative 3 over 2? Let's check. 2 over 2 is 1. 5 over negative 2 is negative 2.5. And a negative 3 over 2 is equal to negative 1.5. And 1 minus 2.5 is negative 1.5. Huh, well, look at there. All that work just to get nothing. Oh, well, I guess that's the answer. So, by the way, what would you do if it was like fill in the blank? You would just type in one answer right there. And that's the answer. Okay? All right, so now we're going to move on to something a little bit more complicated. All right, that's going to be pretty easy. That'll be pretty easy. The least common denominator will be x squared. Just going to multiply that by an x and that by an x. Okay. Oh, okay. This one might be a little bit harder. Not too bad. Not too bad. I'm going to go ahead and pause the video because I got another class coming in, and I got to get them set up. All right, so I'm back to solving this sucker. So we got to find what's called the least common denominator here. Least common denominator, which is going to be an x plus 2 times an x minus 4. That's going to be our least common denominator for this guy. So I got 5 over. I've got x plus 2 equals, all right, 1 over x minus 4. Now, this one, honestly, you could just do cross multiplication, okay? So if you see it like this, technically, if you wanted to, you could cross multiply and do it pretty quickly, okay? So I'm going to do it the cross multiplication way, then I'll do it the least common denominator way, all right? So here we go. 5 times x is 5x, and 5 times negative 4 is negative 20. So 5x minus 20 equals x plus 2. There we got x plus 2. All right, so all we got to do is get all the x's to one side. So I take away an x and I take away an x. I'm left with a 4x. And then I add a 20 and I add a 20 and I get, looks like I get 22. All right, and then I have to divide both sides by 4. And it looks like it's x equals 22 over 4, which equals, if I take half of that, that's 11. If I take that, so basically 5.5 is the answer. So it's either 11 over 2, which is an improper fraction, or 5.5, and that's what I would type in. Okay. Now let's see if this would work. All right. Let's see if this works actually, because maybe I messed up. There we go. Put a 5.5. All right. You can get a calculator too if you want to. All right. So we're going to do 5 over 5.5 plus 2, which is 7.5. We're going to see if it equals 1 over 5.5 minus a 4, which is 1.5. Well, if we cross multiply here, 5 times 1.5 is 7.5, so that'll work. But watch what I do. Right? 5 divided by 7.5 gives you this decimal, which is 2/3, right? And if I do 1 divided by 1.5, I still get the same decimal, which is 2/3. Okay. Now another way, all right, that you could check your answer, all right, is you could go to Desmos to check your answer. Now there's certain tests that you're not going to be allowed to use Desmos to be able to do, all right, but this is a way where you could test to see if you got it right or you didn't. All right, so on this one right here, if I did 5 divided by x plus 2, that's an equation. That's a rational equation. It has a vertical asymptote at -2 right here. And if we take a look at this one, it says 1 over x minus 4. 1 divided by x minus 4. And you'll notice that these two equations, these two rational equations, intersect right there. And what is the x value where they intersect? They intersect at 5.5. All right. Now, I also told you I was going to do this by doing what's called the least common denominator way. All right. So watch this. If I take this guy and I take this guy and I multiply this guy by an x minus 4 over an x minus 4, and then if I multiply this guy by x plus 2 and x plus 2, you'll notice now they have the same denominator. So now I can set the numerators equal to each other. And I still get 5x minus 20 equals x plus 2. If I distribute the 5 to both numbers, there we go. If I distribute the 1 to both numbers, there we go. And we still get the exact same answer. Okay? So that's just another way of thinking about it. A lot of times that's what I like to do. I like just to get a least common denominator and just set the numerators equal to each other. That helps me get things done a lot faster. Not going to do that one, just cross multiply. Okay, so what is the least common multiple? All right, so a least common multiple is, I'm going to give you an example. So let's say we had x squared minus 25. And then I had x squared plus 10x plus 25. Now this one factors to x minus 5 and x plus 5. But this one factors to x plus 5 and x plus 5. Okay, so here's the thing. This one has 2 x plus 5s. This one has 1. So I have to have at least 2 of them. So this least common multiple would be x plus 5 times x plus 5. But what does this one not have? This one does not have an x minus 5, so I have to add that in. So my least common multiple would actually be x plus 5 squared times x minus 5. And that would be the least common multiple. So you have to know what that factors to. You have to know what this factors to. Now this factors to, it's a difference of squares. That's x plus 4 and x minus 4. But this one factors to x plus 8 and x minus 4. All right? Now, what do they share? If they share something in common, you don't have to do it twice. This only has one of them. This only has one of them. So that has to be one of the factors. Then this has to be another factor. And then this has to be a third factor. So you're actually going to have to use all three of those babies. But I'm not going to tell you the answer. All right. Okay, so now we have a problem dealing with rates. Okay, like how long things take. So I'm going to do what's one word problem dealing with rates. So it says Dalen can mow the lawn in 40 minutes and David can mow the lawn in 60 minutes. How long will it take them to mow the lawn together? So here's how it works. I'm going to put Dalen and David. Now, if you mow the lawn, we call that a job, like a job that's been completed. So Dalen can do one job in a total of 40 minutes. And David can do one job in a total of 60 minutes. But if they work together, we can add these two together, and that will figure us out how they can do one job together in a certain amount of time. So, there's a couple of ways to do this. All right. One way is to multiply everything by what's called the least common multiple. All right. So if you ever want to know how to find the least common multiple and you can't do it in your head, you could use the calculator and you could say, all right, I need to know math. I need to go to numbers. I'm going to find the least common multiple of a 40 and a 60. All right. And the least common multiple is 120. If you weren't able to do it this way, where you do 40, 80, 120, and then you do 60, 120, 180, where you count up by 40s and you count up by 60, and there's the least common multiple. All right? So, our least common multiple, LCM, is going to be 120x. Because the least common multiple between a 40 and a 60 is 120. But you got to multiply it by an x. So here's what I'm going to do. Check this out. I'm going to take this whole bad mamma jamma and I'm going to multiply it by 120x. So multiply that, multiply that, multiply that. So here's what I get. 120x over 40 plus 120x over 60 equals 120x over x. So here's what happens. This becomes 30x. This becomes 20x. Not 30. Are you kidding me? What is wrong with you, man? 3, man. Duh. That's 3x. That's 2x. Just pretend you didn't see that, okay? And that's 120, because those cancel out, all right? That divides to a 2. That divides to a 3. I'm allowed to make mistakes as long as I correct myself, all right? Feel free to guilt and shame me. Just do it behind my back. All right, here we go. 3x plus 2x is a total of 5x equals 120. And then we just have to divide both sides by 5. And whatever we get, that will be the number of minutes that it will take. So I said that I was going to show you two ways. Another way is to simply take 1 over 40, 1/40th, and add 1 over 60. Put it 1 over x, and like do it in the calculator. We do like 1 divided by 40 plus 1 divided by 60. Press enter. Hit the math button. Press enter twice. You get 1 over 24. Okay? Get 1 over 24. So I get 1 over 24 equals 1 over x. But I'm not going to tell you what x is equal to. Okay, that would just be too much. So that's how you do rate problems. Okay? Or work problems, that is. Okay? All right. Now, I'm going to do one more because this one's kind of tricky. All right? So we have a slow crew and we have a fast crew. This will be the last problem that we do together. All right? So it says one crew can sow a field of corn in 6 days. So they can do a whole job in 6 days. A different crew can do the same job in 3 days. So they can do the same job in 3 days. If the slow crew works alone for 2 days and then is joined by the faster crew, how long will it take them to finish? Okay. Now, if they both started at the same time, we could just add these together and just set it equal to 1 over x, and that would tell us how many days they would be able to finish. However, they said that the slow crew worked for 2 days. So we don't have a whole job to complete. Here's what you got. Ready? Got 1 over 6 plus 1 over 3 equals. Now, but they don't have a whole job because they've actually worked for what? It says the slow crew worked alone for 2 days. So if they're doing a sixth of the job basically, and they do another sixth of the job, that means they've done 2/6 of the work. They've done like a third of the work is done. So if a third of the work is done, then they don't have a whole job to complete. They only have what? 2/3 of a job left. Now, if you're wondering what the heck I just did, I did like a whole job is 1. If they've done a third of it, you still have what? You still have 2/3 left to go. So that's why I put the 2/3 up there in the numerator. Now, I want you to take a look at this. If I say, what is 2 divided by 3 divided by x? Okay? I want you to understand what that means. Okay? So let's use a number here. Ready? If I say, what's 2 divided by 3 divided by 5? You get 2 over 15. It's just an example, right? 2 divided by 3 divided by 5 ends up becoming 2 over 15. It's like saying 2/3 times 1/5. Oh, wait a second. So 2 divided by 3 divided by x, I could rewrite it as 2 over 3x. Okay. All right. Now there's your equation. All right. If you can solve that baby, you will get it correctamundo. You could add these together and then do a little cross multiplication if you want. But that I'm kind of helping you out with this particular one. That's your equation that you got to solve for now. So I helped you set that up. I'm not going to solve it for you, but I did help you set it up. Good luck.